Hello everyone. So in this chapter we will study about current electricity and we will cover what is electric current, Ohm's law, then combination of resistors, then combination of cells also, and in the end we will see about the electric devices and capacitors, charging and discharging of capacitors. So let's start from electric current. So what is electric current? So electric current is the total amount of charge which is flowing through a conductor per unit time. So current is represented by I, small I or capital I. So I is current is flow of the total charge flowing through a conductor in a time t. So this will be the electric current. Suppose we have a wire in which electrons are flowing, then and suppose a total charge which is Q is flowing in time t, then we can write current will be the total charge upon time. Or we can say here, first of all, here Q is the total charge flowing. And T is the time. If you put charge in coulomb and time in second, then unit of current will be ampere. And this will be denoted by A. This is the SI unit of current. Now if we say the total charge flowing through the cross section of the wire is delta Q in delta T time, then we can say current will be limit delta T tends to 0. That means unit time, and this can be written like this dq upon dt. Right. So we can write like this also, the current I equals to dq upon dt. Now based on this we will solve some questions. So in this question we are given 2 mm long cross section of wire is isolated and 20 coulomb of charge is determined to pass through it in 40 seconds. Find the current in the wire. So there is a cross section of 2 mm length. Charge which is flowing in this cross section is 20 coulomb. Time is given 40 seconds. So I will be total charge flowing through this wire, that is 20 coulomb, and total time is 40 seconds. So this will be 1 by 2, that means 0.5 ampere. Right. Now in this question we are given 10 raised to power 6 protons are moving in the forward direction and the same number of electrons are moving in the backward direction through a cross section of area A in a time interval of 10 milliseconds. Find the current passing through the cross section. Suppose this is the cross section of a wire, and in this direction 10 raised to power 6 protons are moving, and in the opposite direction 10 raised to power 6 electrons are moving, right? Area of this cross section is given A and time is given in which these protons and electrons are moving, that is 10 milliseconds. That means 10 into 10 raised to power minus 3 second, or we can say 10 raised to power minus 2 second. Now What is the current? Current is the total charge flowing through the cross section of the wire in unit time. So this will be the current. Now we have to calculate total charge. What will be the total charge? Total charge will be number of protons into charge on a proton, that is 1.6 into 10 raised to power minus 19. Now electrons are moving in opposite direction, so we will subtract. So it will be minus 10 raised to power 6. Electrons are moving in backward direction, that's why we have put in a here minus sign. So 10 raised to power 6 into charge on a electron minus 1.6 into 10 raised to power minus 19 coulomb. Calculate this. This will be the 10 raised to power 6 into 1.6 into 10 raised to power minus 19 into 2. So this is 3.2 into 10 raised to power minus 13 coulomb charge. So now you can calculate the current. Current will be the I equals to 3.2 into 10 raised to power minus 13 upon time, that is 10 raised to power minus 2. So it will be 3.2 into 10 raised to power minus 11 ampere. So this will be the current through this cross section. Now in this question we are given charge in a form of time, then find the current at t equals to 2 seconds. So here we apply I equals to dq upon dt, right? That means I equals to d by dt of 2t square plus 3. Here current is charge is in function of time t, so we'll differentiate this, then it will be 2 into 2tt, t square का differentiation 2t plus 3 is a constant, so differentiation will be 0. So here current is also a function of time t. So now at time t equals to 2 seconds, current will be 2 into 2. So this is 8 ampere. So here we have solved 3 questions based on this formula I equals to q by t. So I hope आप लोगों को ये समझ आ गए होंगे. यदि आप लोगों को कोई भी डाउट है इसमें तो आप कमेंट सेक्शन में पूछ सकते हैं. Now next, what is the direction of current? So direction of current always opposite the flow of electrons, or we can say same as the flow of the positive charge, right? Now if we suppose this is the cross section of a wire which length is L and cross section area is A. Now if we apply a voltage across this wire, suppose we apply V volt like this, right? So we know the electric field will be in this direction. Because if we move in the direction of electric field, voltage will decrease. So electric field will be in this direction. Now if electric field is in this direction, then the electrons will move in this direction, right? And the current will move in this direction. So we can say direction of current. First is opposite the flow of electrons, or we can say in the direction of applied electric field, or we can say from high voltage to low voltage. This is high voltage end and this is low voltage end. So ये एक बैटरी का सिंबल है और जो लॉन्ग होगा वो हाई वोल्टेज को डिनोट करता है एंड जो स्मॉल होगा वो नेगेटिव या लो वोल्टेज को डिनोट करता है. सो फ्रॉम हाई वोल्टेज टू लो वोल्टेज. Right. Now we have seen I equals to Q by T, right? Now here the relation between electric field, voltage and length we already have seen. E equals to will be V by L here. So remember these formulas. The relation between electric field and voltage we already discussed in electrostatics chapter. Now this question is based on the property of which we have seen ki direction of electric current. So when electrons in a resistor flow from A to B, then potential is, suppose this is the resistor, this is the symbol of resistor, and we denote by R, and now it is given ki from A to B, suppose this point is A and this point is B. So electrons are moving in this direction, right? If electrons are moving in this direction, then electric current will move in this direction, right? And electric current moves from high voltage to low voltage. That means this end will be high voltage and this end will be at low voltage. That means B will be the, it is given greater at A potential, no, greater at B, that is correct. Now drift velocity. So we know the electrons move in a zigzag direction. Why? Because suppose electron is moving in this direction, then it will collide with a ion and its direction will change. Now if electrons is moving in this direction, again this will collide with another ion and its direction will change. So the average velocity of the electron will be 0. Suppose at a time velocity of one electron is v1, second is v2 and so on, then the average velocity will be v1 plus v2, and if n electrons are there then it will be 0, right? Now if we applied a electric field, suppose voltage is applied in this direction, then electric field will be in this direction from high voltage to low voltage, and electrons, there will be some force on electron, that will be F equals to Q into E, Q is there, minus E into E. That means force direction will be opposite to the electric field. So force on an electron will be in this direction. That means electron will accelerate in this direction, and we can write V equals to U plus AT. Right? V is the velocity of electron just after the last collision, that is V, and U initial is 0 plus A. A we can write from here F equals to ma from Newton's law. So this A is here minus E by M. So this is minus E by M, and T is the time, and T is called average time between successive collisions, because after collision its velocity will change. So we are calculating this velocity between two collisions, right? So this will be V equals to, here we will denote VD. VD is the drift velocity, and it will be minus E by M into tau. So remember this formula. Right? So drift velocity of a electron, will be Vd equals to minus E by M into tau. Now suppose this is the cross section of the wire, length is L, and if we applied a voltage in this direction, then there will be the electric field in this direction, and electrons, there will be force on electrons in this direction opposite to the electric field, and electrons will move opposite to the electric field. That means the current will be in the direction of electric field, and suppose current is I, then we can write I equals to total charge upon time, and the another formula which we have seen, that was equals to V by L. Right? Now we have seen Vd equals to minus E by M into tau. Here Vd is the drift velocity, is the electric field, and E value is 1.6 into 10 raised to power minus 19 coulomb. M is the mass of electron, and tau is the average time between two continuous collision. Right? Now I equals to Q by T. That means Q is the total charge flow, and that will be through this cross section. Now if N is the number of electrons per unit volume, then we can write number of electrons in this cross section, and that will be capital N. We can write N into volume of this cross section, that will be area of this cross section into this length. This is a cylindrical we can assume this is a cylindrical wire. So number of electrons which are flowing, that will be n into A into L, and charge of electron, that is E. So this will be, if we calculate the total charge, this will be the total charge into upon time. So this is NEAL upon time. Now, and this can be written like this: I equals to NE into A, L by T is drift velocity. So formula of I is NE into A VD. Remember, N is the number of total electron per unit volume, not the total electrons. Number of electrons per unit volume. So remember this formula also. Now the current density. Current density is the, first of all, this is a vector quantity, and this is I upon A. Suppose this is a cross section, this is the I, and this is the cross section A. Then current density, which is denoted by J, that will be I upon A, and the direction of J will be direction of the current. Right. So, and the unit of current density will be ampere per meter square. Now we have calculated I, that was N into A into L, not L by T, no, we will write VD upon A. So this will be, J will be N into E into VD. Now VD was minus E by M. If we write this, then it will be J equals to NE VD is, if we don't consider this negative sign, then this will be like this. So it will be N into E square into tau also, no? Square E by M into tau, and we can write this N E square tau upon M into E. This can be written like this: sigma into E. Sigma here conductivity. Conductivity of the material. So we found this relation: J equals to sigma into E, J equals to sigma into E. Remember this. And sigma is conductivity, which is N E square tau by M. Remember this formula also. And the another relation is sigma is 1 by rho. Rho is the resistivity. Now tell me the unit of sigma. Unit of sigma will be, from here we can see, this is ampere per meter square. Unit of J is ampere per meter square from here, and unit of E is volt per meter. So we can calculate the unit of sigma, and unit of rho will be the opposite to the unit of sigma. So remember these three formulas. and this one also, J equals to I by A. Now we will do some questions based on these formulas. First question is, assume 1 ampere of current is flowing through a copper wire of 2 millimeter square cross section area. Then find the drift velocity of electron. If number of free electrons in 1 centimeter cube copper is 8.5 into 10 raised to power 22. So फर्स्ट ऑफ ऑल ये जितने भी फॉर्मूलाज आपने अभी तक स्टडी किए हैं इन पे बेस्ड वन क्वेश्चन श्योरली आता है. लास्ट रिक्रूटमेंट में भी एक क्वेश्चन पूछा गया था, उसको भी हम सॉल्व करेंगे. सो फर्स्ट ऑफ ऑल हम लोगों ने एक बार क्विक रिवीजन कर लें क्या क्या अभी तक फॉर्मूलेज देखे. फर्स्ट फॉर्मूला देखा I इक्वल्स टू क्यू बाई टी या फिर डी क्यू बाई डी टी, राइट. सेकेंड हमने देखा E इक्वल्स टू वी बाई एल, जो कि इलेक्ट्रोस्टैटिक्स में भी हमने स्टडी किया था. देन हमने देखा ड्रिफ्ट वेलोसिटी दैट इज माइनस ई बाई एम इंटू टाउ. देन हमने देखा करंट डेंसिटी J इक्वल्स टू सिग्मा ई या फिर I अपॉन ए, एंड सिग्मा की वैल्यू क्या आई थी एन ई स्क्वायर टाउ बाई एम. देन हमने देखा सिग्मा इक्वल्स टू 1 बाई रो, राइट. सो ये फॉर्मूले हमने अभी तक डिस्कस किए. एंड हमने I का भी फॉर्मूला देखा इन टर्म्स ऑफ वी डी, दैट वॉज एन इंटू ए इंटू एन इंटू ई इंटू एरिया इंटू वी डी, और वी कैन से एन इंटू ई इंटू ए L by T. Now in this question we are given the current electricity is 1 ampere through a copper wire of 2 millimeter square. So area is given 2 millimeter square, that means 2 into 10 raised to power minus 6 meter square. Then find the drift velocity. We have to find Vd, number of electrons per unit volume, that means small n is given 8.5 into 10 raised to power 22 per centimeter cube. If we calculate this per meter cube, then it will be this, right. Now I equals to n into E square into Vd into A. So put the values in this formula. Then this is 1 ampere and n is given 8.5 into 10 raised to power 22 into 10 raised to power 6. This will be 6. Vd is already given. No, we have to calculate Vd. Area, that was 2 into 10 raised to power minus 6. So you can calculate this and we'll find the value of Vd, right. So इन क्वेश्चंस को सॉल्व करते टाइम फर्स्ट ऑफ ऑल हमें फॉर्मूलाज याद होने चाहिए. सेकंड, जितनी भी वैल्यूज हैं आपको SI यूनिट में पुट करनी है, right. Now mobility, what is the mobility? First of all it is denoted by mu, right, and it is defined the magnitude of the drift velocity per unit electric field. So what was the Vd? Vd was E by m into tau. Now if we divide Vd by electric field, this will be E by m into tau. The relation was minus with minus. Now here we are writing only magnitude, so this will be mobility, right. So formula of mobility will be E by m into tau. right? E is the mass of E is the 1.6 into 10 raised to power minus 19 coulomb. M is the mass of electron, and tau is average time between two continuous collision. So remember this formula also. Now SI unit of mobility is we can calculate from here. Vd by E, unit of Vd is meter per second, velocity unit is meter per second, and unit of electric field you can write from V by L, volt per meter. So volt per meter like this. So meter is square per volt second, or you can write the SI unit of E from this formula also, right? Now this mobility is directly proportional to tau, and similarly we have seen sigma was, the formula was sigma was n into E square tau by m. So this sigma also directly proportional to tau. Now we'll solve a question based on this formula. Assume the average time of collision between two electrons inside a conductor is 2 millisecond. Find the mobility of the electron. So tau is given 2 millisecond. Mobility was Vd by E over E into tau by m. So mu will be, well, is the charge on electron 1.6 into 10 raised to power minus 19 coulomb. Mass of a electron, that is 9.1 into 10 raised to power minus 31 kg, and tau is given 2 millisecond, that was 2 into 10 raised to power minus 3 second. If you calculate this, then we will find the mobility. Now what we have studied in this chapter? So here is a quick revision. What is the current? Current is the flow of the net charge passing through a conductor per unit time, right? And what is the relation between electric field and voltage? That is E equals to V by L. So रेड ले लेते हैं यहाँ पे ताकि वाइट पे शो हो. Drift velocity is Vd equals to minus E into E by m into tau, and I equals to n into E A into Vd. N is number of electrons per unit volume. Current density is J equals to sigma E. Sigma is the conductivity. Conductivity is the sigma equals to n into E square tau by m, and mobility is E into tau by m, that is Vd by E. सो ये सारे फॉर्मूलेज आपको याद रखने हैं, एंड इन पे बेस सिंपल क्वेश्चन आता है. आपको ध्यान रखना है कि सारे जितने भी वैल्यूज हैं वो आपको यू हैव टू पुट इन एसआई यूनिट, राइट. सो इन नेक्स्ट लेक्चर विल स्टडी अबाउट बैटरीज एंड ओम्स लॉ and combination of resistors.